Hi guys, my name is Bob Greenyer and I'm a volunteer with the Martin Fleischmann Memorial Project. So today I have some sad news and I also have some good news. The good news is that I have received a number of papers, as I hoped I would, from Takaaki Matsumoto. Some of them are in Japanese and some of them have a translation. What I did was, this was the first day that I could get to them to have a decent look at them. In fact, I had a little bit of a look the other night, but this was the first one I attacked was this one on the discovery of micro tornadoes. And I was absolutely blown away because in the bottom of the image there was something that I recognized. And it does not surprise me that Taka Aki Matsumoto observed these things first. Anyway, before we get on to that, can everyone hear me? Can everyone hear me? Hi Artifact, hi Gardy, hi Charles, hi Corky, hi Jason, and hi Lucas. Okay. So I'm hoping to do a rather special presentation this week because I think I need to put out another one for Taka Aki Matsumoto. It's related to this presentation and I need to translate that as well. I think I might shift that, so I'm going to exercise possibly some time travel on the presentation that was scheduled for tomorrow. It's going to move into the future. Excellent. Okay, so sound is good. Okay, so the first thing I want to show you is something from the work that I did in India in 2017, and it was the first time I was there, and I just happened to have my GoPro and capture something at 240 frames a second. And it is very important to have high-speed camera photography to be able to understand something. Now, I have talked about this video at length, and I called it Sprites, and it's detailed as Sprites, hydrodynamic structures caused by helical ultrasonic sound in water. Well, sounds very grand, doesn't it? But I think it's exactly what it says on the tin. Anyway, we're going to look at this, and essentially, you won't hear any sound at the moment. It's pretty shrill ultrasonics. I'll deal with the sound in a little while. But here we go. So these are producing what you might think are just bubbles in the water, but there's a much more complicated structure to them. And we identified that they can eat each other, they're very stable, but then they grab each other ones, and even though the flow of water is in one direction, they can pull other ones of these structures very, very rapidly into them, almost as if the water is not important to their speed of travel. They seem to be able to move faster than the water would allow them. Given on the flood, you can actually see these very small particles moving around, and there was another feature in here that I think is quite important, and that is towards the end, where you get these kind of sprites that come on the glass of the tube here, and maybe I can capture one as it comes to. It's towards the end of the video, maybe in this video. Let's hope it's in this video. Otherwise, I'll be talking to myself. Okay, maybe it wasn't there. Oh dear, sorry for the advert. Yeah, I must remember to turn off adverts when I'm trying to show something, or just use the recording that I already have. Okay, so I've got to play that through, haven't I? Oh, how annoying. So I'm going to kill my audio here. Now, relevant to what I'm talking about today is that there was an agreement made today, which I am extremely sad about, and that is that the Japanese government have voted to allow the discharge of the tritium water, that's well over 1.2 million tons of tritium laced water, into the Pacific in 2 years' time. That is our window. Now, I've got the news article here somewhere. It was sent to me by Dave earlier today, and I'm not happy about it. But you may or may not know that when I was with Dr. Roshin Amaza, he told me that in 2011 he was with TEPCO engineers, a news crew, and Japanese politicians, and they took the tritium water. I think it's 12.48, something like that, years for one half-life of tritium, and they used his vibrator technology in some of this water, and in 14 days it reduced one half-life, and in a month it reduced 74% of the original emissions. And that means it's done, to all intents and purposes, 2 half-lives in 1 month. And the significance of that is that if this was going on since the beginning, then you know, you wouldn't have these 1.2 million tons, because this was done in 2011. And essentially, I am told that the data and the video and everything was not allowed to be showed. And this is you know, his story. I can't independently verify that. But when he told me this, I knew that cavitation can cause transmutation. And I also had, on the day one, brought the Ultra mic, the 384 kilohertz mic, and the hydrophone that I had constructed. And in both cases, we confirmed the production of ultrasound by his 178 hertz vibrator fins. Now, in the literature, obviously, Roger Stringham had done a lot of work and had shown transmutation. It wasn't at that point that there had been the work by Tom Claytor showing that ultrasonics can transmute to a wide range of elements, not just fuse to deuterons into helium, as was the bulk of what Roger Stringham had done. But we do know already from Leclerc and from other authors that cavitation in other forms had caused transmutation to all elements in the periodic table. And if you push it too hard, then you will actually create radioactive elements, and that's the case with Leclerc. So the gentle vibration of the work of Dr. Roishin Amaza is working at the bottom end of the construction-destruction of this technology. And therefore, it's not surprising to me that it was able to do the transmutation, even though I had not done the experiment myself. And of course, tritium is a beta isotope, and beta isotopes, if you have, according to Alexander Parkhomov, they are highly susceptible to this radiation that can be produced by actual cavitation. And this was confirmed by Shishkin. The great levels of cavitation in a rotary vane sort of hydrosonic pump can produce the type of radiation which is known to manipulate the rate of decay of beta isotopes. And tritium, being a beta isotope, should be influenced by this. And we do know tritium can be created by Lena in the form of corona discharge in the work of Tom Claytor, and that's verified. And also that tritium is produced at the beginning of cavitation in light water. But tritium has 2 neutrons as well, so it's a good feedstock. So we have to work as a community, because at that time he didn't know his system was producing ultrasonics. I proved that. Our team proved that day one in Japan. Ultrasonics can transmute matter. So what we didn't know until very recently is exactly how that is going on. And I think we're getting to the point of being able to full spectrum explain how that is occurring. And I think the paper from Taka Aki Matsumoto, which was written and presented in 1999, by the way, can form an important part of this puzzle with other data that we have, for instance, from the Lion reactor and other examples. I've got a sample on the microscope, which I'll show you later, and I've talked about it a great deal in the past, but it's the Ballburn sample from 1986 from John Hutchison, and it has this same magnetohydrodynamic structure on it, where you get these overlaid things. One's a hole and one is either a peak, or if it can't be a peak, it's a flat thing, but it is still changed in what it looks like. Okay, so we're going to look at that, but I'm going to pull up this sad but true news article, if I can, first here. So let me put that up there. So this is on CBC news here, and it says Japan to start releasing treated radioactive water from Fukushima nuclear plant in 2 years. Residents, fisheries officials and environmental groups denounced the decision. This was from 3 hours ago. Today, Fukushima Daiichi nuclear power plant is seen from Naimi Town, Fukushima Prefecture, north of Tokyo. Japan's government said on Tuesday it has decided to start releasing massive amounts of radioactive water stored in tanks at the wrecked Fukushima nuclear plant in 2 years after it has been treated. And now, when I say treated, it's still going to leave the tritium in there. Okay. Japan's government announced on Tuesday it would start releasing the radioactive water from the wrecked Fukushima plant and so forth. Long-term impact unknown. Oh, well, let's dump this in the sea and find out. So I haven't read it all. There's this whole list. So here you can see that these tanks here have the Fukushima water in it. And what it is, they can use technologies to remove some of the other heavier and more long-lived isotopes like strontium-90 and cesium-137 to a degree. But you just basically can't get rid of the tritium. And so that is a real problem. Residencies, fisheries, officials and environmental groups issued statements denouncing the decision as ignoring environmental safety and health and further hurting Fukushima's image and economy and the fisheries. So we have an opportunity with a technology that has already demonstrated at TEPCO with the water from Fukushima that it can remove the tritium from this water. But I don't blame the scientists, because the literature out there that dealt with transmutation was talking about ultrasonics. And I can tell you, when I went in, he did not know it was doing ultrasonics. He did not know it. Day one, he knew it was doing ultrasonics. He did not know it was doing cavitation. End of day one, he knew it was doing cavitation. And at the end of day one, we also saw our first strange radiation track coming out of a cavitation spot. So in one day, the whole situation changed. And in a couple of days, I introduced them to the work of Takaaki Matsumoto, and now Sho helped me reach out to him. I thought he was dead, but now we know he's not. And on that note, even though I'm immune, they won't allow any foreigners into Japan. I'm going to try the business letter argument, and maybe I can go on that basis. But failing that, we are looking to organize a laptop, because he doesn't have a computer or he doesn't do anything online with video calls or whatever, and try and get that to him, and Sho will go and we can go over his material and at the MFMP's work and the work since he retired in other areas, and try and understand some of the more specific details about his work and everything in between. So he's 80 years old, and it is absolutely a opportunity that we have to make happen as a community. And armed with this knowledge, we can go, and there's no point going to the government. You have to go to these residencies, the residents, the fisheries and environmental groups in Japan and in neighbouring nations, particularly South Korea, who are really against this, and speak to these people. The government have shown, and technical engineers, if we are to believe what Dr. Royshin said, they have shown that they are not interested in using a solution. But the situation has changed. As I said, we now know how it is working, and that how it is working does transmute matter. So it's less of a problem for them to accept that it is doing what it's doing and something else didn't happen, which was just an artifact. So it's a different situation. So if these particular groups that you see on this table that are somehow informed that there is a potential solution to dealing with this radioactive water, then I think we have a 2-year window to put a stop to this. And I would suggest that it would be a case of, not only do I think we can fix this, it is absolutely an abomination for us not to be able to try. Moreover, because tritium has 2 neutrons, it's quite favourable as a partner in transmutation. this tritium water could be extremely valuable to synthesize rare elements. You could start with the tritium water, which you can't get every day of the week, okay, and put in salts of other materials and end up with valuable products. So if we can't get them on the side of the groups that are rightly protesting against this, maybe there's a commercial argument where you could come in a commercial argument and say, well, you've actually got a massive resource that you're threatening to throw away and upset a load of people. So I think if we work together, that there are people out there that might see this video, that might have the wherewithal to speak to the right people and ensure that this is given a chance to work. And so that's what I'm going to say on that for now. Now, I want to introduce you to the paper by Amasa, not by Amasa, by Takaaki Matsumoto. And I have it here, if I can find it, in Japanese, first off. So let me get that up there in position. Okay, all right. So how's everyone's Japanese? Okay, so this is Discovery of Microtornadoes from, it would appear, September 1999. Matsumoto Takaaki. And it's got a couple of English references there. And down the bottom, there is something which I will show you when I do the English version. So let me just get that up. So what I will do in the days following this presentation is I will post the PDF of this work and also the translation and some other material that is relevant. So it's so raw. I mean, I only finished the improved translation this afternoon, and it's a very short document, but I think its significance is what we need to consider, and how we can replicate the necessary process, I believe, in the ultra type experiments. And I will say, hopefully by the end of today, if Alan finds the time, he's going to try and run an experiment and capture some of these magnetic particles, and potentially we might have an answer as to whether the transmutation is going on in the top of these magnetic particles that I've been sharing over the last couple of days. Anyway, here we go. So this was presented at the proceedings of the autumn meeting of Japan Atomic Energy Society in Nagata Institute of Technology, page 63 for this document, and it was done in 1999. Discovery of micro-tornadoes. Taka Aki Matsumoto, Department of Nuclear Engineering, Hokkaido University, Sapporo, Japan. Abstract. Micro-ball lightning, which was generated and controlled during underwater spark discharges, was discovered by the nuclear collapse reaction during its transport through wires. Okay. So, since small whirlwinds can be generated by the rotation of wind, it was ordinarily considered that large-scale tornadoes could also be similarly made. However, tornadoes have such high rotational energy, they cannot be explained by such a fluid-based origin, and the cause has still not been clarified. Still an edit to do there. Let me do that right now. This is real time. Lightning strikes could give us a clue, though. Here, intense electrical discharges could generate large itonic clusters, enabling electrical nuclear collapse. The itonic clusters, which were generated during underwater spark discharge in the laboratory, could be very stable and can fly freely underwater or in air. It seemed to be similar to the curious shining, naturally occurring body of ball lightning, BL. Therefore, it is called micro-ball lightning, micro-BL. Micro-BL could be self-compressed by the strong force of the itonic cluster, inducing nuclear reactions inside. Also, because micro-ball lightning is negatively charged, It is attracted to the anode and can transport through wire leads, called the second electrical current. Now, this is the paper that I probably will tweak the translation on and share tomorrow. For a very good number of years, Takaaki Matsumoto thought he discovered this, okay? And I asked, because it was in that book, and he did, sorry, the reference to it was in that book, but it wasn't in the book that I have. I asked him to send this. I've glossed over it quickly, and I can tell you, Takaaki Matsumoto identified exactly what I believe is going on in this so-called different type of electrical conduction. I believe this was observed by Tesla. We know that Tesla blew up a power station, and I have argued a number of times that it is because of exotic vacuum objects being conducted into the wires that blew up his transformer in the substation. C.I.C also lost a large transformer substation. John Hutchison lost or lost a big transformer. And also, when I was with Suhas Ralkar, when we were doing the plasma flow discharges to do his specialized type of coating, he had a very large three-phase transformer, and I have captured on video and shared in 2017 where you get these great big flashes, and it produces a pressure wave, and you can see the water squirting out, and the whole room is illuminated. And I've caught it on 3 or 4 different cameras, and at that time the huge three-phase power supply would trip. I believe that is exactly this process. Now, whilst Takaaki Matsumoto claims to have discovered this type of electricity, if you look at Tom Bearden's book, this one, I believe, Fer-de-Lance, here, it talks about him visiting people in the Soviet energetics program in 1992, and they demonstrated the transport of high energy over very thin wires. And in the early 2000s, there was a presentation on a national channel where they showed that they were using 8-micron wires, and they were lighting 25 kilowatts of light bulbs. And what they were using is a Tesla coil and a spark gap. And so they were 100% certainly creating exotic vacuum objects, and that was what was conducting through this very fine wire. And the key point here is that when this gets into an inductor, the filament in the tungsten filament light bulbs, any inductor that it goes into causes these things to disrupt, and they shed their electrons, and so you get a lot of light. But if it goes into a transformer, it will blow it up. So Matsumoto thought he had discovered this in the 90s. It was discovered and turned into technologies by the Russians prior to 1992. And it was the bane of the work of John Hutchison, of Tesla and C.I.C, and they suffered as a result of this. This is why that I have said that technology that uses this may suffer overheating in power supplies and so forth because of this. So I will go into more detail, but Takaaki Matsumoto, I think, is the first one to have produced a document and made it public. And I didn't know this until two or 3 days ago, who specifically says that it is this type of what he calls an itonic cluster, which he conceded in 2001 is probably an exotic vacuum object or equivalent, but he's certainly saying here in this document it's micro ball lightning, and it's a technological equivalent of the natural phenomena. And by the way, the natural phenomena causes wires to blow up and things, so you know there is a total match between what happens naturally and what is observed with technological production of ball lightning. And so I think the credit really could go to the Russians, but for the first person to absolutely call it, I think you'll find tomorrow that will be Takaaki Matsumoto. And it is a great shame. Reading this paper and translating it today, I was so, how should I say, disappointed that it took me until 2018 October to come across his work such that was published already, and it's just a great shame that fusion technology changed the rules so he couldn't publish from 1994 onwards. Otherwise, many people would have seen this work sooner and we would be a lot further ahead. With that, we'll continue reading. So in this report, underwater spark discharge experiments were conducted using two types of anode, a palladium wire 0.5mm thick and about 12 centimeters long, and a small knife-shaped copper strip 0.2mm thick, about 10 centimeters long. By the use of continuous DC or pulsed AC discharge, microball lightning was generated at the tip of the anode in the aqueous solution, controlled and driven to the other tip of another anode. So what I think he's saying here is he has a cathode, he has an anode, it's in water, which is a solution with maybe some potassium carbonate he typically used, and he shared the kind of molar concentrations that he would use for that. And then he has another anode, and I imagine, and I will clarify this with him, that he creates the ball lightning on the end, and you will have seen this in our Vega experiments, and you will have seen this in various types of water discharge experiments. I think some great work has been done by a open researcher called Can in Italy, and the ball lightning on there, and what he's saying is once it's stable, he then switches this off as an anode and then has the other anode turned on, and it travels from one to the other, and so he can then see what happens along the track of the technologically produced ball lightning. What damage does it produce, and what transmutations does it produce? And this is just a brilliant technique, and I hadn't heard about it till today. Why is that? And the fact that this was shared so many years ago, more than 21 years ago, this was shared. This is a travesty that this happened. Anyway, you know now know it. Okay, so let's go on. So, by the use of continuous DC or pulse, I'm going to change, I've got an inconsistency up there, I'm going to fix. So, he confirmed the generation and breakup of microball lightning. Figure 1, we'll come to the figures. He confirmed the movement of microball lightning on the palladium wire. And that might be in the palladium wire, I just need to check that. Confirmed the snake-like meandering traces of microball lightning. Where have we seen meandering traces? I don't know. Where have we seen those? Observed nuclear transmutation on the tip of the palladium wire. This is where the microball lightning is formed first. Confirmed generation of film and tube of carbon made by the nuclear collapse on copper plate. Now, we made many tubes of carbon in the Parkhomov 225-day reactor. When I am going to talk about what is O, I'm going to share something which conclusively shows the formation of a film in an unexpected experiment to have done that. But anyway, just saying we have observed film, and I expect that we will find that there is a film of carbon on the Vega Valley sample when we look at it. Okay. High-speed spout from microball lightning. Emission of fast rotation microtornado, figure 2. The explanation by the NATO model. So I guess there was a verbal presentation. We don't have the verbal presentation. This was the premise for the presentation. Now, I want to share you the two images. One of them you can make out. The other one, sadly, is a little bit difficult. But the first one is confirm the generation and breakup of microball lightning. So let's have a look at that. And here is the image. Partial breakup of traveling, or I guess it's traveling or moving ball lightning. Now, when I saw this, I thought, well, I know what I'm looking at there. Essentially, you have these semi-periodic damaged parts here, and on the opposite side, they are like, it's like a screw. They're not directly opposite. And I've seen this before. And where did I see this before? Well, I saw this before in the work of Lion, and I shared the video many moons ago And I have it here. He says, I have it here. Okay. Give me just 1 second. He says, maybe 3. Give me a little while. Okay, so if you were able to look at this earlier, you will already have seen it. You may have already seen it before, but it's here in this video, and I've actually got it queued at the right point here. So that is the structure. Okay, zoom in a little bit more. Maybe. Is it going to let me play? You can go and have a look at this in your own time. But it was chopping across multiple tracks. We know exotic vacuum objects can carry other ones with them. And this was, I believe, I don't know whether I was using the Narugo or I think I might have been using the Narugo. So you can see these kind of tracks where you've got the board line in the center and then these alternate structures either side here. So I knew exactly what I was looking at when I saw that at the bottom, and it just made me chuckle, because the guy's absolutely amazing. It doesn't matter what I think I found. I've always said it's just a realization, because all you had to do is to look at linear experiments that are genuinely linear experiments, and you will see all these kind of structures. It's like they just appear. So I actually presented this at Sochi, and so this is just running into that. This is Dmitry Baranov here down in the running this session down the bottom, and it's in the next slide actually. Oh no, not that slide. So if you go and look at this video, I'm actually specifically saying that it's spiraling through this material down the bottom here, and I actually play with my hands how it's cutting through that material. Maybe I do, and maybe it's just before that. It is just before that. Okay, there. I go over and I say spiraling through. Okay, so. But I have to say, I never ever had seen one where you actually had the structure that did it. And of course, the Takaaki, he's been doing this a long time. And when you look at what he shows here, he's actually got the toroidal structure at the end. There we go. So it's going through. Now, this isn't the only time that I've seen something like this. Subsequently, I got some material from, let me see if I can find it, from one Alexander Parkhomov. Now, whilst I'm showing you something that was in fused quartz, which is melting at 1,706 or whatever degrees centigrade it is, what I'm about to show you was in boron nitride. And you almost don't get anything that melts or is a hotter sort of, it takes more to damage it really. It's pretty demanding stuff. So let me see if I can make this so you can see it. Maybe not. Yes, okay, I've got it here. So this is tracks by Parkhomov. And you can see that there's a long track here and a longer track here and a short track here. So it's a similar kind of structure with the lines. And there's several ways you can imagine this occurring, but Alexander Parkhomov was very sure that this is a very more complicated type track to explain. But I think this is the same type of family of track. And it could be that there are multiple structures moving along, or that it's one. And as it goes into this boron nitride, which is the second hardest material there is after diamond, it goes, and also like diamond, it's covalent, which means exotic vacuum objects really have a hard time destroying it. So the fact that it is means this was quite an aggressive one. And it comes in and it starts churning up the material. So you might argue that it starts over here on this side and it gets bigger and bigger and bigger. In fact, you know what I'm going to do for you guys? I'm going to switch my mouse to make it bigger so that you can actually... I promise show that I would do this. So show this is for you. And I'm sure other people are saying, I can't see the mouse. What is he going on about? So I'm going to make my mouse so it should be really clear for everyone to see. Okay, let's try this. There we go. Can everyone see that? All right, that's a big mouse. So it might have entered over here. And as it went in, it started chopping off pieces of material. And they are spinning around the torus. And as it goes down here, it's chopping off more pieces of material. And 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 by this point, it's got so many pieces of material flying around it and smashing up the boron nitride that it kicks it off. And all you do is you see the tail end of what is going on. And what am I talking about, the tail end? Well, I believe the tail end is the tail end of this vortex, this tornado. So a tornado can pick up chunks of houses and cars and whatever. What can a tornado pick up? Let's have a look at the kind of like an extreme thing that a tornado can pick up. Like I'm talking here about a real tornado. Let me find a video here. It's a video, but I don't think I can show it because it's, well, I don't know, it's on another YouTube channel, but you may have seen this, and if you haven't seen it, you can easily find it online. So let me see if I can find this particular video, because it's quite important to what I'm trying to get across here. Where? Somewhere? What did I do with it? Okay, there we go. And what are we in? We can dump that up there. Okay. So in this video, this is a tornado in Dallas. And it's picking up, I think these are 36-ton trailers. And I'll just, for the interest of science, I'm going to play just this little clip of this. Because you'll see that they aren't immediately whipped up and like they just gently rise and they're gently put down. In a minute you see this is the trailer. This is a huge piece of metal and steel and so forth being gently lifted up and gently laid down. So, what I'm suggesting is that this is producing a tornado. And in the second image, which he says above is high-speed spout from a micro ball lightning emission of fast rotation micro tornado. He has this structure here, and it's really not very good in terms of resolution. But there is a ring here at this end, and then there's a conical structure coming out of it. And for me, this is essentially showing what would create this structure. And if we go back to the Parkhomov data, let me find that. I believe that is consistent with this damage mark that we see here. So as I was saying, the EVO comes in, the EVO does its horizontal stripe damage, but it is creating in its tornado, in its wake, as you see in the image of Matsumoto, it's starting to capture pieces of material and smash it through the surface. And it gets more and more and more and more and more and more and more until it can no longer withstand the deflection force, and it starts moving away. And as it moves away, you're seeing it getting bigger because you're further down the tornado cone. And I have shared the structure that I believe created this many moons ago at my Sochi presentation, and this was a realization that came to me in the middle of the night, and it is, in my view, the structure of O, the basic structure of the exotic vacuum object toroid, and if I can find it, like I say, if I'd had more time, I'd have done a better presentation. It's also in that Sochi presentation, so let me see if I can find the relevant part. So let me show you that. So that is what I'm referring to is this, and you have the vortice going around, and it creates these kind of butterfly shapes that you see on the Lion reactor, and you have this tornado coming in here, which is a conical structure, and you kind of almost have, it's not a singularity, but it is a certain point of maximum compression, and it's a vortex compression. So there we go. And if you compare that to the slide from Matsumoto, we'll make this smaller and pull it down, and you can imagine perhaps not that one. You can imagine perhaps that this is the, I've got half a ring here. So if this is the whole ring, what you're seeing is the trail that's behind the ring at more as is in this image. And I will endeavor to try and see if we can get a better shot of this damage. But this is damage caused on, he says down here, micro tornado deposited on small copper plate. So again, what he's doing is he's creating on the anode a ball lightning, as many authors have done, and then he's switching off this anode, and let's say you've got the flat plate of copper, knife shape. So you've got a knife comes down to a point, doesn't it? So that you get the ball lightning forming on the point, and then you have another anode. You switch off this anode, and it travels along the copper plate and touches the anode, and you get the structure. So this is a way to study the shapes that this forms. So before I go on to the evidence that is already captured, by the way, in 2019, by the first person to take up my challenge of doing some ultra experiments, one Thomas Kaminski, I'm just going to see if you've got any questions there. Let's see if my mouse works. Right. Let's see. Okay. Okay, so I'm. It's good to see that people are behind the trying to get this technology recognized by humanity. We have a small window to stop that pollution being dumped into the Pacific Ocean. If you live on the Pacific Ocean or you don't, this is an ocean that washes the water around some of the most populated planets on parts of the Earth. And so if we have a solution that can fix this, or we think we do, we should at least try. What percentage of the mass of water gets transmuted? From a question from Riandathal. I don't know, but if your water is emitting 100% of the radiation at the start of the test in the Amasa vibrator tests, the proportion of whatever you take that as the ground level of however much tritium is in that water, and then by the end of 30 days, you effectively have only 26% left of the tritium, because the emission rate has dropped by 74%. So one would assume that there is a lot less tritium in that water, and so the rate is that much lower. You're suggesting the inference is that you have already stimulated the beta decay of the tritium isotope. Clean up and make dollars, I think, is an easier sell than clean up and pay us a little bit of money. I think I'm not wrong in saying it's certainly in the $400 million $400 billion they've got earmarked for fixing Fukushima between now and 2050, and I don't think that will fix it. That's just the budget for there. And I think it's even as high as $750 billion, so 0.75 of $1 trillion, right? And you know, the sort of technologies that you're going to be seeing coming out of the work that we're doing and others in the field could fix that for a small fraction. And this is where the demands of people who want what they call, in certain circles, disaster capitalism, where you make a very big hole, everyone worries about it, so they're willing to spend the money, and then you fill it in, and in the meantime there's a very large amount of money sloshing around. You employ a load of people and so forth, but people are living in fear, and there is actual real risk to people's health and happiness and to the environment. And so if they create a problem and there is a real solution to fix it easily, we should actually be trying to, as people, ensure that the easy solution is used rather than the one that's going to let us live in fear for generations. Okay, so WP for Truth, if you had something that did this, how would you distribute it without being stopped? You don't have a very large YouTube channel, and you tell people how to do it beforehand and ask them to download the YouTube videos and disseminate them. Having a big and large presence might lead you open to being shut down rather quickly by vested interest, and there is a lot of vested interests. So fly under the radar, get it out so it can't be undone, basically. But I think in the past, where there were only a few channels where you could publish through, if you were stopped from publishing as effectively because of a rule change in fusion technology, Taka Aki Matsumoto was in 1994, then even lifelong nuclear scientists with a specialism in radioactive remediation, and that was his focus even before 1989, couldn't get the word out. And he would go to conferences and honestly, the people at the conferences, they've got their own little fiefdom, or they've got their own little technology that they think is how it's done. And so they will watch a presentation, but you know, in my experience, quite often they're not even reading the paper when it's published, because it isn't their ideas. It's not invented here syndrome. But ball lightning exists. It's real. And what he's showing in this very short paper is you can make it, you can control it, and in the path that it is controlled, you see the effects of something that is producing microtornadoes. And then microtornadoes are causing damage, which has the pattern of some forms of strange radiation. Thanks. I'll look at the nonic. What I'll do is I'll publish a PDF and it'll be on a Google link, and I'll be able to update that. So if you see some typos in there, just let me know. Or if you know someone that speaks Japanese and you think that from the Japanese there's a better English translation that's more accurate, then go ahead. Let me know and I can update it. And then anyone that looks at it from that point will see. Charles, I did publish on Steemit, but then they started allowing adverts in, and then it was sold to a South Korean, and I lost. What I wanted is persistence, so I've asked several people. I know there's one at least watching now that have used the software 4K downloader to capture our channel. So you know. So he was asking about persistence using blockchain technology, I believe, or giving advice on it. Okay, I'm going to show you some videos. They were actually made public in late 2019, and at that point it was really only a couple of people that had tried ultra experiments, and he was the first person that I presented to at the IEEE in Madison, Wisconsin, And due credit to him, because he replicated these sprites structures, and you'll see that, but also you will see micro tornadoes, and I will try and capture better video of that in the coming weeks to share that with you. Corky Goss, I have zero maths. A number of years ago, I think it might have been at the beginning of 2018, I said I commit to trying to explain this entire technology without one mathematical equation. What I wanted to do, whilst I have referenced works of for instance, Puthoff for describing how the solitons are able to condense electrons, and I have pointed to the work of Lutz Jaitner. What I've tried to do is, and I'm trying to do, is to show the entire technology and the family of technology and what it can do. And I've hinted at anti-gravity today, by the way, and you'll see more of that. Without showing a single equation, where you can just see what it's doing, and you know that that's what it's doing, and you can see how it's done, just with video. So that is my aim, is to basically make this so a 5-year-old could understand it. I'm not saying you're 5, I'm pretty sure you're not, but I'd like it to be able to be understood like an apple falling from a tree. Yeah, Washington State really, if you watch the plume from the original Fukushima accident, the kind of like, as I understand it, people were tracking the isotopes in fish, and then they stopped allowing that to be done. Now, tritium gets into your body, and all the time it's in your body, it's going to be decaying at quite a fast rate. It's 12.45 or 12.47 years or something like that. So that's a faster rate, although I think it's a lower energy than some of the other isotopes. Cesium-137 is 30.7 years, and strontium-90 is like 29.8 or something like that, around the 30-year mark. And they're really, really nasty, because one replaces salt in your body, and the other one replaces calcium in your bones. So, but the water being replaced with tritium, not good. And it'd be like, oh, a few extra 100,000 people died of cancer over the subsequent 100 years, and it would be like, oh, that person's dying of cancer. It's sad, isn't it? Oh, yeah, people die of cancer. But the being able to attribute it to a dump of material in the ocean will be impossible. But we are in a position, I believe, to prevent that from happening, and ideally make it into a commercial positive. Make that water extremely valuable. That's what I'd like to see, because then you turn the tables on it's a burden to it's a resource. Yeah, Soldatron, Corky, yeah. Would a double Evo even be a whirl wave object? Okay, well, I think what you're kind of seeing. Anyway, we'll talk about that at a different time. Actually. Okay, all right. Yes, Axel, I believe that is the case. I believe from what I observed on. So Axel is saying it's like a permanent magnet. From what I observed on this structure, and I derived a 3-tiered fractal version of the exotic vacuum object, I believe that the structure is static, but it's actually moving other material around it because of the fields around it. And I believe that if we go back to the image from Matsumoto and from my own image and from that of hold on, from here. So there's the straight lines, and then the structuring across there. Let me see if I can find my this one. So in this image of Parkhomov, you've got the straight lines, and the straight lines, in my view, are caused by a part of the structure which is static of the exotic vacuum object. And maybe I can pull up my idea of how that shape is. But material can be chopped out with that, and then it gets caught up into the ability of the structure to spin material around it. And so, and particularly in the vortex that it creates in its wake. So let me find my structure, and then you might understand a little bit more of what I'm talking about. Let me see here. Okay. Be with you in a sec. I'm just watching an advert. Okay. So what I'm referring to here is this, which it came about by looking at the 2007 sample of John Hutchison on, and I published this on the 17th of February last year. And so this is what I'm talking about here. And so you have a EVO substructure here. And this has a suppressed north pole and a strong south pole, or a suppressed south pole and a strong north pole. But they can still link together. And so they link together and they form a closed loop. And then this structure spins magnetically around it. And so then this has a suppressed north pole or south pole and a strong south pole or a strong north pole. And then these can link together and so forth. So you get links around links, and then links around links, and so forth. And so it's fractal in its self-organization. And this is why it's quantized. And it's quantized also because you can make a ring out of less than this number of subunits. So you can have a ring that's made out of like 6 of the units that you see around here. There's actually 48. And the reason there's 48 is because that's what I counted on. So this is me talking about that. And then I found the D4D ratio here on the 1950s work of Bostic. And so then I showed that you have the substructure here is D4D, and then it's a substructure on a bigger one, and then this bigger one is the substructure on the bigger one, and then you get this certain type of track mark, and it's tighter on the inside and fatter on the outside. So everything was on that exotic vacuum object strike marks on the Hutchison fracture sample. And so you can go and see this video, and interestingly you can see the sort of hexagon shape that you see here, and there's probably a good segue to the next part of this presentation. So let me just pull up that. Okay, so in the title frame of this video I showed several things, and I will walk through them now. Okay. Okay. So this is the title frame for the presentation, and up in the top left-hand corner you can see the toroid of the microball lightning structure here, and the wake caused by, I believe, the tornado and the material that it swept up as it traveled to this point and then stopped. And over on the right here you see a close-up shot of what I observed in the beginning of 2018 on one of the Lion reactor outer cores. And then here we're going to look at the video which shows many of these. And the interesting thing is that I don't know whether that's a sonoluminescent spot in the center. But if it is, then this would effectively be your EVO with your itonic clusters, according to Takaaki Matsumoto. And it's creating the uplift and everything to create the micro tornado that goes down to the base, just as it does in real life. And you will also see that there is a massive uplift of material here. Now, is it an explosion bubble that's causing this to lift up? I don't think it is, because if you watch the video that I'm going to show you, then and you will have access to all of these videos, the uplift is fairly consistent, and it also has a very hard boundary around it. So, you know, Takaaki Matsumoto in his paper in 1999 is saying that it's not adequately explained the rate of spin of a tornado on a normal hydrodynamic or a fluid dynamic sense. There's something more interesting going on, and in his case, he absolutely 100% knows that it was due to what he calls an itonic structure, and others might call an exotic vacuum object, and he also calls it microball lightning. And so, you know, he's saying that that causes the spin, and that in a thunderstorm you get the same thing, but it's caused by electrical discharges. The interesting thing is that Ken Shoulders explained and made the argument that it was ball lightning that forms all electrical discharges. Now, I've got 3 images in here that I'm going to walk through each one, and then I'm going to show some video of it. And this will explain why there is extreme need for high-speed photography. And I can tell you today that due to the support of a donor, that we hopefully in 6 weeks' time will have access to a camera that can do 1920 by 1080 at 1000 frames per second for about 11 seconds, but they will be DNG frames, so they will be uncompressed. So we won't have all the compression artifacts that you're having to deal with when you've got a long group of pictures in a typical phone camera or other types of camera, or the problems that I'm getting on the microscope that I'm viewing here, where it's meant to be doing 30 frames a second, but it occasionally puts out a frame. So you get the same frame for several frames. So not ideal. Okay for normal microscopy, but not for really understanding what's going on. And you'll see that when I show a little GIF animation of what you're looking at in this shot here. But it will do, for instance, 640 by 480, which is the same frame size, roughly, as what you're seeing here. But it'll do that at 5,406 frames per second, uncompressed, for 11 seconds. And the absolute beauty of the Ultra experiments is you can run them, you can look through the viewfinder, you can find out where one of these figure of eights has got the vortice going on. And once you've established that, it works in that spot for a long period of time. So you just kick on the ultrasonics again, wait until it's in frame and it's doing its business, and then you hit the record. And so we have something here that is absolutely every time repeatable. Okay, so this one you're seeing here, I will overlay because it may not be immediately obvious on you. But there is a bubble coming through here, or a rising volume of water, 1 or 2. But when you look at the next video from Thomas Kaminski, you will see that there is a upthrust of material, as you would imagine would occur where you have a micro tornado below. And so you have this upthrust, which is going through this aluminium, but it also collapses down. So bizarrely, it makes a pit. And I don't know if I can capture it in this, but if I don't capture it, there is an amazing part in one of the Thomas Kaminski videos where you have a micro tornado, and then the micro tornado collapses, and it then has a pulse, which is exactly where it would need to be to form one of these figure-of-8 structures, that comes up alongside it, and it shoots the water up into a cone above the level of the base of the water. This is going to be so repeatable that people will be able to observe this. And so I put the challenge out for the first person to get the best shots of this effect occurring. But we're going to be understanding what's going on here much better. Now, if you look at this, you will see that this is divided into 120 degree segments. We saw this on the back of the affected fused quartz in the Lion reactor. And you can see that it has this bulk area in the center, but then there's this other ring of substructures around it. And this overall structure looks very much like the structures that we observed as deposited material of some type on the inside of the supernova reactor, being born somewhere, traveling, and then being deposited on the inside of the supernova reactor. And if I overlay right here, if I get it in the right place, there is a hexagon at this point. So let me zoom in, and maybe this will be clear. But as we get better photography and as we get better time resolution, these things will move from being reasonably clear to being completely clear. So you can see that there is a line here to a spot here, a point there, a point here. Interestingly, this is a white point, and this point is a black point. Is that relevant? There's a white point here, and there's a black point. On the black point, you have it going over on the 120 degree. There's a black point over here, it goes on the 120 degree. So is this important? This white point here, this black point here. I think it will become important at some point in the future. So there is our hexagon. And you can see that every other point on the hexagon has the dark dividing line on it, and every other point on one of the sides, or every other point is a light line, as it were. So there we go. That is that structure. So this would be giving you an indication of what's going on in the actual reactor. Now, I have a GIF anim of this, so let me just see if I can find that for you. Now, bearing in mind, it's missing frames, and so it's doing it the best it can, but it's not doing it very well, to be honest. But anyway, let me see if I can find it. Okay, so I've slowed this down 15 times. Oh dear, what happened there? Let me see if I can get it roughly the same size. Now, this was a point in the video which I've already shared where I'm moving the laser pointer around. On the plus side, it means that you can see the bubble better. On the negative side, I am moving the laser pointer, so it changes the illumination on the surrounding area. So I've made it black and white to make it a little bit easier. So you can see the implosion explosion going on here. Now, this is at best 7 frames a second, and it's just caught some out of sequence overall parts of the process. We know from many videos we've already shared that this is producing intense vorticity, absolutely intense vorticity. But here you can see some other substructure of what's going on. Okay? So there's that. In this video, which is actually of the same structure but at a different time, you've got a piece of detritus that comes in. It stops dead at this point, and it gets thrown back round and travels over the top of this one, goes over here, and kind of stops and comes back again. Anyway, we'll have a lot better material. Actually, it comes down here, stops, comes round and goes up the side of this, round the other way, and comes towards the camera and then disappears out of shot. Now, back to our overall title slide. We have this one, And this is using the Narugo microscope. And what I'm talking about here is this $70 microscope here, which I put onto the Samsung S7 or other cameras, but on other phones. But in particular, this one was on the S7. And you can see almost very clearly the hexagon in the center of this structure. Okay, and so this is the pit and this is the spike. It does appear like there's some sort of other damage in the core of this, and potentially a hole in the top of this one. And if I overlay on this the hexagon, that's where the hexagon is here. So I'm going to zoom into that. So this is after an experiment on a Narugo microscope. So there's the hexagon in that shot, and it's much clearer. Now you can also see vortex features here as well. So I'm hoping that Alan Goldwater will do one of these experiments with his Vivreal this afternoon with some fairly thick aluminium foil. Capture with a magnet some of these ones that seem to be captured by a magnet, and put it under the SEM, and we should get a much better imagery of what's going on here. So that's the hexagon on material afterwards. So we've already shown in the reactor over here, in the ultrasonic tank, after the ultrasonic tank. And then in this case, I replicated the work of Dave, where he just ran his tank for a little while and put in a magnet and captured some pieces, and he found some vortex structures on there. And in fact, I've got some here. This is one that he did on a replication of his own work again. So these two are supposedly magnetic particles that he picked up, and both of them have this vortex structure on. Okay, and I talked about these. Actually, we'll leave that there. So we'll go back to this one. So so this is a magnetic particle, and in the center you can see that it has. Remember, we saw over here we've got 3 dividing lines on this one. Well, we actually have 3 structures on this, and I talked about this in a separate video yesterday, this is replicatable every single time. I mean, I didn't even bother running the device again. I just used the detritus that was in the bottom of the tank from the previous Friday, and I put the magnet in on this little thing here. That's it there, just a magnet with some tape around it. And I picked up 3 pieces, and I looked at the biggest, and it was this. And it has this hexagon structure on it. So if I go to what I'm looking at here, we have a hexagon type structure here, and you can see that across 2 planes you get a wing, across 2 planes you get a wing, across 2 planes you get a wing. It's not perfect, excuse me, because it's ripped out of the material, but that's what we see. Okay, and then we will come out, and I will just see if there are any questions before I go on to look at the videos of these structures, and we'll end up where we began in terms of looking at sprites, but replicated sprites. Okay, so what do you have? Have you got any questions? Dan Moretti, yes, I had the pleasure to meet Dan Winter, and you have a little soundbite on our MFMP channel. It's creating what I call a black donut, or it's certainly compressing things into an extremely small point. I would argue that it's not much smaller than an alpha particle, but they can be overlaid. But it can have the density, according to Lutz Jaetner, of a pulsar and 50 megateslas, 50 million teslas, and essentially 5 times denser than the center of our sun. So it's not surprising that you get transmutation, and hopefully by the end of the day we will have one of these little magnetic particles captured in a 3 or 4 minute experiment, put under the SEM, confirming whether or not we're seeing transmutation in those dark spots or the center spots. And is it because of that they're becoming magnetic? Or is it that an exotic vacuum object is getting trapped in that bit that gets ripped off, and it's presenting as magnetic, but it isn't actually a magnetic material? There's a thing that you can't see that's presenting as magnetic. So there are reasons why this could be magnetic. And John Hutchison in the 1980s found he could convert non-magnetic materials into magnetic materials. And this was also observed and documented and put into a paper by Taka Aki Matsumoto in 1995. So it's not a unique finding that you can create magnetic materials that aren't magnetic normally. The fact that this is producing conic structures here, I would suspect that the conic structures here have a specific form which makes them stable given the energy structure that's interacting with them. And I think that if we do a proper confocal laser microscopy, I think we will probably find that it's a very, very interesting shape that is being made, and you will see it all over nature. I'm looking forward to seeing your videos, WP for Truth. That's interesting what you're saying about spinning the magnets. Well, the slow-mo guys might be able to do it, but the camera that I'm looking to use will be able to take the actual macro lens that I'm already currently using. I hope that it will be able to pass power to it so the ring light will work. But it means that we can capture exactly the same frame that we've been capturing before, but without compression and at 120, 1,000 uncompressed frames per second at 1920 by 1080p. Might be able to, it has a C mount on it, so should be able to get some planar microscope lens, and because we know that we can find these things and they don't move around once we've got a good one in not too an active area, because if we have it in too much of an active area, it ends up eating it away, so you just get a hole. So you want one that's in not the best, most intense energy area, and then you can work with that with a microscope and bring your field of view down to something really tight, and then use lower resolutions but much higher frame rates, like in above 5,000 frames per second. And I think we're already learning a hell of a lot from 30 and 60 frames a second. I think we're going to learn an immense amount from those much higher frames per second, and we're actually going to be able to work out, I hope, the speed of rotation of material that gets trapped in the vortices. And then other people who want to do the maths can then work out, well, this is a large block of material and it's being spun around, what is the force that's being exerted to make this travel through the water at this speed? I was just laughing at Christoph F's. He ate a whole packet of cookies. Oh god, oh dear. Yes, I think it would be worth. So WP for Truth is talking about putting his coil in water and it sings. I think it would be worth recording the sound and recording with camera as well. Yes. Corky's transmuting a beer. Right, I'm going to get onto the videos in a minute because there's quite a bit of video material to get through. I'm going to play one straight the way through, which will be the correct aspect for what we're looking at here, and then I will go and show some frame by frame ones, and hopefully we can capture this spike that occurs, but you'll see a lot of tornadoes, and you will know that this is going on, and cavitation isn't just straight cavitation as we've been led to believe. Evo is like the folded edges of the aluminium that is parallel to the vibrating plates of the ultra. Okay. Yeah, well, it'd be interesting to see your videos of that. So, Altverland1 is suggesting putting folds into the aluminium so that there are some focal points for the structures to act on. And yeah, I know Dave yesterday or today, whatever, Canada, pleated some aluminium to create more of the magnetic structures to be able to look at under the microscope. Yes, Diadon, I'm very, very much looking forward to see what Alan can come up with. If he... Basically, I said to Alan today, I said, look, it was your piece of serendipity that observed these first three structures in the indium, you know, and combining that with there is so much material to share from both the Amasa vibrator material, with indium that was exposed, and I've shared a lot of that, but also that which was exposed to Amasa gas, which is just amazing. It was in my ICCF 22 poster, and if you look hard, you can see it, and I discuss it at one point. But it's absolutely incredible what's going on there. But when this little piece of serendipity happened, I said we need to take this seriously. This is a really easy thing to do, and if he is able, or he sees transmutation in a ordered structure. So if you go and look at the Amasa vibrator plate one, where I see, and I talked about it in my last presentation, I think, where I see these helical structure on the figure of 8 that was deposited on the palladium-coated foil, palladium-coated plate, where you have the two structures, and in one of them there was a carbon, possibly a diamond crystal in there. You had the magnesium, which is 2 carbons fused together, and you had the chromium, which is 2 magnesiums fused together, and they were in helical sweeping motions. And the helical sweeping motions, they tend to have these 2 or 3 arms, and it looks a lot like you are seeing in what you're seeing here with the 3 arms over here, these 3 arms, or if I can find them again, the structures that were shared by Dave. Let me see if I can find it here. So it's kind of like we call it the eye. I called it the eye. So there's 2 wings. You get 2 wings, okay? And it's the same kind of structure where the transmutation was occurring in the Amasa vibrator plates. So if he observes not just the fact that it's got material in that overall section that's ripped out of the aluminium foil, but if it has this vortical structure with different synthesized elements on the compression wings of the spiral galaxy, let's say, like you can imagine a spiral galaxy has this going on, and on those compression zones you end up with the formation of stars and planets in higher concentration, and so you can imagine it's the same thing just on a different scale. And I'm sure Winston Bostic would be very happy to see his words repeated by me. But effectively, he's saying that plasmoids, as he called them then, were doing something that would explain the formation of things in the cosmos. And so if he finds that, then we have absolutely slam dunk proof that you can replicate every day of the week by 5-year-olds in a primary school that can show we can transmute matter. And as we know that tritium is so unstable, and we've already got the data from 2011 claims from Amasa that it can deal with the radioactive waste you actually have something where you can go, well, this 5-year-old did it over here, Mr. Super Engineer at TEPCO, or Mr. Brilliantly Wonderful Politician. If 5-year-olds can do this and they can show the transmutation, why do you want to dump this waste in the Pacific Ocean? Seriously, guys, come on. My child did it. He's not even at school yet. You might have to get to that level of spelling it out for them to be able to make this to move forward. Alan will do it eventually. I hope he does it today. No pressure, Alan. No pressure. If you're watching, but he's on a holiday, a well-deserved holiday tomorrow. So, and I've asked him to do something else as well. Someone has made a special type of device to look at thallium-205. Transition to lead-205. So we are sending the scintillator from GS 5.2 that produced what we call signal, which I believe is the breakup of an exotic vacuum object, and subsequently I believe it's the breakup of an exotic vacuum object inside the scintillator. If we see thallium-205, then we know that a cold neutrino detector can readily be made. And so you will be able to detect these things in technology like Sapphire and Vega with some accuracy. Yes, I believe this is the seed of the universe. I will talk about what is O either tomorrow, but probably I want to do the paper on Matsumoto's publication that he saw this alternative type of electrical current. I think it's fair to him. Like I say, the Russians did technologically utilize this first, but it was under the Cold War program, and it was only chanced upon by a visiting scientist in 1992. Russian scientists were desperate for funds. They were spilling the beans. But you know, it's important that the fact that he actually published this first, even though many people suffered as a result of it before, he actually should get credit for being the person that tried to tell people. I shouldn't worry about robots, because with exotic vacuum objects you can you can EMP them. That's it. Done. Just this is easy to make EMPs. Robots are never going to be useful on the battlefield when everyone's using this technology. Seriously, it's like, sorry, you've wasted a lot of money. Okay, so I am, unfortunately, David, in an effort to protect ourselves from exotic vacuum object experiments, we are exposing how to defend a would-be nasty robot. However, it's just dependent on the scale of the exotic vacuum object that sooner or later you will be able to destroy everything, and I mean everything. And they know that. I'm not telling bad actors what they don't already know, which is sad in its own right. Okay, so I'm going to start pulling up these videos, so give me a second to find them, and then we shall have a look. If I get my mouse on the right machine. Okay. Aha. Did I plug that in? This is what is it? Whatever. Okay, no, it's in that one. Okay. Okay, we're going to love this because you can now see these videos that were shared late 2019, probably early, yeah, I think late 2019. Let me get the date for that. So these videos were made public around November 2019. But now you're going to see maybe with a whole new set of eyes what's going on, those that did see them before. So let me just see if that's... So the first video I'm going to show you is rotated because it is? No, because I rotated it so that I could publish it and it would be a better orientation to look at. So let me switch to that now. Okay, got my ugly mug over there. Okay, right. So his aim was to try and replicate the sprites that I showed you at the beginning of this presentation that I observed in Suhas Ralkar's ultrasonic tank in India in 2017. And I'm going to play this. Now, you'll notice that in the Viv Real, it has the max mark there. And on my How To Kids video, I showed me filling it a little bit below that because when I put in the our boat here to put the foil on, which Thomas Kaminski actually did. We discussed it back in 2019, but without the foil on, just to get a better look at these sprites. And I've got that video for you somewhere here. It displaces some of the water to bring it up to the max. So I've operated this mostly at the max. But if you put less water in there, it does different things. And when you get to not, you know, this is, I guess, 40% up to the max mark, you'll see you get production of these sprites, and I will play this now. I will not play the audio because it is really just going whee, and it's really unpleasant. So I'll just play the video and you can see what happens here. Great. And you can all try it really easily. Look here, what have we got? We've got two counter-rotating vortices. And periodically they put down a whirlwind, a tornado. There's plenty of tornadoes going on. And you can see other micro ones being born and then merging together. All the sort of things that you saw in the Suhas Ralkar video. But what you didn't see is you can see, I'll let it play through and then we'll go through it frame by frame, maybe in a different orientation. And I'll put it into Premiere so that I can zoom in. And we're back to full frame speed here. So he filmed that at 240 frames per second on a Google Pixel. I don't know which one. And so you're seeing the slowdown there. So I'm just going to find a nice looky frame on our twin vortex structure in this part of the frame here. So here you can see we have one vortex this way and one vortex this way. So you can immediately see how you would end up with this two-sided spiral arm galaxy. The exact same thing that we are observing when we are looking at these structures here, if I can, will it, oh no, it won't let me put these both up on the same frame. Let me do this. If I do that, then I can show one alongside the other. So you can see how you have the spiral coming in here and the spiral coming in here. So this wing here is this wing coming into here. And this wing over here coming to the point here is the opposite side here. And I imagine that this might be raised and this might be dipped, possibly. But what you can definitely see, if we step through this, is that many times, so there's actually a micro tornado over here. You can see the plume. You get a very, very hard edge, and then you get a dome above it. And look, there's a little bright spot in the middle. And I don't know whether this is the Evo itself, and this is the tail, and this is the plume. And you're actually seeing, in hydrodynamic terms, the mushroom that you see on those Russian strange radiation impacts onto film. But I think with better photography, we are going to be able to define this extremely well. And so you can see there's a kind of micro tornado. So what I'm going to do is I'm going to rotate this. Look at this. I mean, it's just like, it's going mental there. So I'm going to rotate this round. And you can see how this structure pulls in energetic structures from all around it and concentrates the energy that's going on in that. You can see the bulb above here, the bulb above here. So you literally have this kind of like tree. So I'm going to get this into Premiere. And before I do that, I'm going to show you a series of other videos so you can just get a feel for what's already been done. And here, look at this. I don't know if this is obvious to you, but this looks like it's raised up a lot. So there's an opportunity here for people to get cameras very down and close and personal to this. And in fact, I might use the waterproof endoscope to try and capture these effects, but looking at the level of the water and see if we can capture these coming up. But this looks like it's really coming up into a high peak. But of course, I've rotated the camera, so it looks a bit odd. And in fact, in one of these videos, we have a thing that dips down, forms a big vortex, and then like almost immediately it throws up a massive spike somewhere here on some part of the video in another section. But I spotted it earlier, but not for some of the day here. Okay, so let me go and get the other videos. Wardenclyffe mushroom. Yes, Corky. It's an energy structure. The whole thing is an energy structure. It was designed to make energy. It wasn't just designed to transmit energy. It was designed to make energy. Right. So I shared this links in the video that you're watching right now, and you can go and have a look at them. Let me go and let me switch here. So so this is looking more top down, and you can see the domes and the vortices going on. It's not slow motion in this case, but you can see the sprites here. And in fact, this has got 1, 2, 3, 4, 5, 6 arms on it. And this has got a dome right here at this time in. Great blue ocean of opportunity for people. Look, we got one vortex here and one vortex here. Are these connected? Do these slightly in point to something? Do these in point to this structure over here? Do they? Do they? It's very dynamic, of course. Okay, so we're back to the beginning on that. Let's look at the next one. Now, you can see here we've got 1, 2, 3 structures. 1, 2, 3. What is this little squiggle here? Look how much this is domed up. But also look at how hard the edge is. It has a point that is extremely, it's like water. It's like straight, straight, straight and up. Now he's got a mirror underneath this or very, very reflective piece of foil. So you're getting to see that what looks like a shadow, but you're actually seeing the same thing twice in that. And this is another approach you can try to potentially see different things. So you can download these videos and play around with them. This one's not so interesting at the moment. Let's see if we find something interesting in here. No, there's just a little plume over here. It's not so interesting. This might be the one I've shown you, but at a different angle. I think what I might do, yeah, this probably is the one that I'm going to put into Premiere for you. What's this? See how much that water gets lifted up? Okay, so I've got one more here. So this is the one that I've rotated, I think. Yes, this is the one that I've rotated. So periodically you'll see these structures like this one here, which is obviously more like a tornado than other structures. And it was that one that I grabbed for part of the title slide that you saw earlier. So with a macro, looking at this at 1000 frames a second, 1080p, we're going to get a very good understanding of what's going on. So exciting days ahead, exciting days ahead. But there are actual cameras out there that you probably have friends that have them. I think the Sony does a short clip. There's a Sony phone that does a short clip of 960 frames per second. It's real, although there will be long groups of pictures. And so what if it's just a few seconds? You can just keep going because this is such a repeatable experiment. Okay, so I think that's that for that set, and then he has another set here. And this is where he was using the glass bottom boat approach. He's got a few air bubbles under there. So you don't see the upwelling so much, this so-called tornado anti-gravity that I showed you in the shots earlier. But, you know, with the right kind of... And by the way, he's using a bike light, something similar to this, which I have here. It's an extremely bright light here. If I shine it into the camera, it'll probably blind you. There we go. And side lighting the tank like I did in my collection of magnetic structures yesterday. And so you could, in his case, it's not the clearest thing. He's suffering from my problem of having not such a clear thing. But you can see the vortical structures right here on this point right now. So many ways to study this. So that's that one. So thank you, Thomas Kaminski, for taking me seriously and going out and getting yourself a ultrasonic tank and running these experiments in 2019. So yeah, these are less interesting than the ones I showed you previously. So let me get the first one into Premiere, and then we can zoom in on it a little bit, maybe with a little bit more predictability. Any questions? Okay. Gordon Doherty, you're pretty good for 2.5. Looking young, looking young. WP for truth. Is it because he used a 3-phase system? Is it because these things tend to have hexagonal structures with 3 wings? I don't know. This is as above, so below. Yes, definitely. Kaminski is a serious dude, yes, really. Do you record ultraviolet light? I do intend to get the spectrometer in there. I did actually do a recording using the 90D, the Canon 90D the other day, but I didn't change the sensitivity. It has a very, very high sensitivity range, and in that first video, even with the exposure cranked up on the recorded file, I didn't see anything. So I will try using the 90D, but I will change the sensitivity, the ASA, very, very high. Plus, I will do what Thomas Kaminski has done and lower the water level so that it produces a lot of these sprites and these tornadoes, because I believe that's where you are going to get the most intense potential sonofusion type events, or sono transmutation, let's call it, because it does seem to produce, if you look at the work of Tom Claytor and of Leclerc, and my studies of the work of Suhas Ralkar, the unexpected transmutations in his fuel processor, which is just meant to make things smaller, but it actually did appear to transmute matter. These are the more intense ones. So I'm expecting when you're seeing these sprites, as I call them, I think that's where we might be more lucky to find illumination rather than when the tank's full. Did I see any cool robots in your trip to Japan? Um, what I did notice is you often walk into a restaurant and you order everything on a machine. And this is familiar to you guys in America, but in Europe you tend to have a waiter come to your table and you order off a menu with a person. But typically you would order off a machine and it had, did you want your soup like strong, medium or weak? Did you like your noodles hard, soft or sloppy? There was everything that you could ever complain about an item of food that you could choose off one of these machines, and then you gave this code to them, and then they would produce exactly what you asked for. That's kind of a robot. Robot is actually a Czech word, and it means worker. Sorry, random trivia there for you. It wasn't seemed to be possible from me the other day when I did the test with various laser colors. I have this ultraviolet laser here, and it's mostly violet, but it does go into the ultraviolet. We looked at this on a spectrometer, and what I want to do is to test this again with the vibrator system, but in the mode that it's producing these sprites, and also in the mode that we've been trying before, to see if there's any shift in the light. It would appear there might have been some shift to orange, which it shouldn't really have. Or it might have been preferentially absorbing light and giving an indication of a different light. But anyway. Now, what are the sprites? Are the sprites fingers of intense compression? Or are they kind of like lightning underwater? Or are they ionization trails? I think but what you always see is the sprites go to a point. There is a point at which these fingers come out. And is that a point of self-compression? The itonic cluster is made at the point of maximum harmonic Q and incident of energy, and it then causes itonon clusters to form. They explode or compress and then explode, and out of it shoots these ionizing beams which cause nanobubbles potentially in the water to grow and collapse in a lightning-like fashion. Yeah, so I had a thought the other day where, and someone might like to try this before me. There's a challenge. So I got this LED, and I was wondering, because exotic vacuum objects should explode out electrons, or the EVOs themselves are conducting, can we know where we're seeing one of these vortical structures, the figure of eights, can we tip an LED into that, like this, an LED, and ground the other side, because ball lightning likes to go to ground? And can we get the LED to illuminate? That would be an absolutely stunning observation. And I haven't done it, but I've been thinking about it. I've got the LED, and I would probably choose one that's not a white LED, because they need more volts or whatever it is, current or whatever. I would choose like a basic, say, green LED. And see, either if it's where we see these sprites, put it in the water and ground the other leg, or put it in the vortex point of one of these figure of eights. That's the bit where you see all the action going on. Will we see an LED illuminate? Yeah, we know, trying to speed up the half-life of tritium. Well, we know that cavitation does that from the work of Amaza in 2011. Certainly from his claims, but since we know it does transmutation, and I demonstrated that his system does transmutation, although we didn't have tritium water, you could say therefore it will transmute tritium. Yeah, well, Artifact says put a dentist X-ray pad in there and hope it survives. Well, they are waterproof because they're meant to go in people's mouths. I'll show you what he's talking about. He's talking about these little puppies. Oh, what have I got there? That's like the little gift for you at the end there. Okay, I'll show you that later. I've revealed my little Easter egg. This is one of these dental X-rays, and they're designed for putting in the mouth. The X-rays on this side, and it's like 3 by 2 centimeters. You put it in there, and you get your X-rays, and you see you've got some teeth, or you've just got a load of gums. But anyway, it has a self-development thing in here, and this is actually something that was used by Lion at first, and you can buy these, a pack of 50. They claim they come from all kinds of places, but they typically come from in India because they still use them there, and it's very easy to work with, and so yes, that's not a bad idea. Is there always lightning present to see a sprite? I think you're talking about sprite in the sky. I think they're related effects. I think you've got a large exotic vacuum object that's formed in the environment, and it has one effect below and it has one effect above. It's all the same thing, it really is. All of it's the same thing. Use a bit of titanium foil that is distressed with electric arc as per Mizuno in order to anchor the Evo to a spot. Well, yeah, I mean, aluminium is very reactive with water, and also when you get above a certain temperature, so is titanium. Yeah, it doesn't have to be lightning, but there has to be an Evo, I believe. So that's Gordon about sprites. Okay, so I'm going to now see if I can load this into Premiere, and we can just have a look at some particular frames, maybe, if we're lucky, if it all goes to plan. Let's hope so. And then don't let me forget about my little Easter egg at the end. Don't let me forget, okay? I'm gonna make that your job, Corky. You gotta remind me. So that's the one I want, I think. Is that the one I want? It's one of these. Yeah. Okay. If you're watching this in playback, you can skip to the bit where I've got it in Premiere, because I'm not saying much of any use right now. Sorry, I will be with you. Okay. So we have our sprites here. Maybe I can zoom in a little bit because we don't care about the bit that's at the top because that's above the water. So we'll go to about here. Maybe. Okay, let's see if we can see anything of any use. I'll probably wait until it gets to the slow motion bit. Right, so we're in the slow motion bit. So straight off the bat, you can see that there's this raised area above the sprite, and this wasn't possible to see when we were doing the video in 2017 in Suhas Raukar's lab. Okay, so you can see how bulbous this is and the vortical structure to it. And look right there, you get a strong peak coming up, strong peak. Here's our friendly 2 down here, and you can see this clear figure of 8 structure. It's a clear figure of 8 structure. So let me zoom right into that. So we have no doubt that what we are seeing is going to happen every single day of the week. There we go. Figure of 8 structure. You see it moves around a bit because it's got nothing confining it. It's overly dynamic. It's riding on its own wave function. And you can see here like the spiral arms. You've got one spiral arm there, one spiral arm there. And look, they come into the center. There's your figure of 8 and so forth. In fact, there's another one off to the side in that particular shot. Now you can see the kind of tornado structure forming. So we'll come out because there are better ones of that. Let me go back a bit. So, okay, we're back about here. So areas we're going to look for tornadoes is one here and one here. And you can imagine that these are on resonant areas. So here we can see a sort of tornado forming. And it's kind of rotating around. It's like a spinning top. Here, like you can see it here. Again, if you look down the bottom left, I've got the frames here. Okay, so there's another double structure here, you can see. So I'm going to zoom into that so you can get a better idea of what I'm referring to there. See this double structure here, vortical structure. You see that spike coming up here. This isn't the best example. And again, the compression is causing all sorts of problems. So having a better way of recording these things. Like I say, the problem now isn't not the repeatability. The problem is having a clear understanding of what's going on. Although it's pretty good. It's pretty good. Because of the time resolution and compression artifacts. But we're going to fix that. And if Alan gets the time today, we might see beautiful SEM images of one of these structures, these caps, these magnetic structures that get formed. Look at the tornado structure down here. Lovely. And look at there's almost an explosion here. Look. Huge explosion. Look at the inversion there. This is a big pit with a spike in the center. Look at that. Look at that. It's like a dish Boom. And look at our tornado we get left with. Oh. Wow. You don't need to be a genius to do this. Trust me, I'm not. And you don't need to have a lot of money to do this. This is something you can do in your kitchen. And you can deal with the wife's jewellery afterwards. Honest, I just want to clean your jewellery. You look so beautiful in it. Okay. So here you can see it's like back down to a single vortex, but maybe its partner has drifted off somewhere. But it really is, you see the two arms. Boom. There's a lovely one forming up here, and you can see the structure to it. And I reckon with a high-speed camera with the right contrast, we're actually going to see literal hexagons being formed on the surface of the water. It's just going to be amazing. A real tornado now. It's got these wings that are coming out and dragging in these structures here. We've got another one forming over here. Now, I want to say something here because I think I'm right in remembering this. The spiral bits on the Amasa vibrator plate, they were, as far as I remember, magnesium. And the bits on the outside were chromium. And it's like there is a piece of depressurization on those spiral bits. And if you go back to the video here, and I just step back a frame, so I'm going backwards in time here, you can see here, this coming out of here is a kind of this white beam, but it's not coming from the bottom structure down here. It's coming from this one, but it's moving into this one. So is it that chromium was made and it was depressurized into becoming magnesium? And at the core, it was depressurized from magnesium and became carbon. You understand? Go and look at that study that I did of that Amasa helical structure, the figure of 8. So there's a figure of 8, and there's a carbon at the core, then there's these arms of magnesium, and then around the arms of magnesium, you've got chromium. Divide chromium in two, you get magnesium, and right at the core, you get carbon. It's ripping matter apart. Bear that in mind. It's ripping matter apart. I'm going to come back to that with an unimaginable image later in the week. Really, it's quite spooky to look at. But what you're seeing here is these what look like dendritic structures coming out, but they're not. They're coming in, and so they're being depressurized as they go down. It's not. It's nuclear regeneration. And Matsumoto nailed it when he said it's like it spits out carbon at the end. And as you go towards the tip, you get the heavier elements get lighter and lighter. Remember what I showed on those quantum coherent, instantaneously formed crystals on the titanium that was exposed to a Mars gas and then touched the polytetrafluoroethylene, which is made of hydrogen and fluorine. You got these crystals, and the crystal had magnetically self-organized spikes growing off it, and on the base it was like nickel, and then it was iron, and then it was chromium, and then it was titanium, and then it was carbon. So it's kind of like it's depressurizing on the way down, and that's what you're seeing here, and that is what you're seeing on that Amasa vibrator plate with that helical structure. This is absolutely unimaginably awesome. And you get to see it first. It's just... When I tell you what I've said to myself, what O is, and when you start to grasp what you can do yourself in your own home and begin to understand, it's just breathtaking. It's just... really, honestly. So you can see some very, very clear plumes here. So you've got your sprites around here and then this bubble of stuff above it. This one over here, you've got your sprites down here. What's this thing up here? Like it's like in the center point above the sprites. Oh, look, there's a shot up. Look, you see this? Sudden shot up. Watch it, watch it. Boom, boom. It's like one frame and it goes up really high. There is an example over here at some point, which is just, it's amazing. It's so clear. It shoots up so high. Okay, I think you get the idea. Okay, so now I'm going to show you something which is on the Bulburn sample from 1986 and was made by John Hutchison, I think in Canada. And I've talked about this sample a lot and I've talked about this structure quite a bit. But I think with what we've seen in the last, couple of weeks, you can begin to understand more of what you're seeing. And see it for what it really is, and I will show you now. So let me see if I've got it in shot. It's kind of in shot, but I'm going to go to the wide shot first. Okay. Okay, so hopefully this will be okay for you to see. You'll have to let me know, and maybe I can fiddle with the polarizer and pull out different features. Okay, let's show that there. So this is on the Bulburn sample, and what I'm drawing your attention to, and I don't know whether I can't actually point to that, can I? Can't point to that. I'm drawing your attention to the almost hexagonal shape, which is kind of right in the center of the microscope image, and the same shaped object just over to the right. But the fact that they overlay each other basically the same way that these magneto-electrical hydrodynamic structures overlay each other in this figure of 8 fashion. And what you see on one side is a hole, and on the other side you see something that's the same shape, but it's not really a hole. It's kind of a changed structure to the material. Of course, this is a solid piece of steel. I can show you it. I'm going to pull it out and I'll show you it. Here it is. For those that have not seen this sample before, I'm talking about this. This is the Bulburn sample, and I'm looking at this area over here. And if I go maybe into here, you can see up a little bit close and personal. No, that's not very good. Okay, all right, stop picking that up. But anyway, this is the sample, and I've got beautiful macro photos of this, and you can see that. So let me see what I'm kind of trying to show you here. And so I'm talking about these features over here. I'm going to rotate it round so we get the best. There we go. Those two structures there. Okay. So like I say, I've shown these many times before. I'm going to change the polarization here. So you can see with the polarization changed that the structure on the left, which is the one that isn't the hole, is much brighter, and the one on the right is the hole. And if I change the polarization here, you can see that they are the same shape, roughly, and they overlay each other. When I first saw this, it was like, what is going on here? How is that even possible, that these things are like that? And but anyway, now it should be starting to be demystified. Okay, So I'm going to change my magnification here to 200 and something times so we can have a look at both structures. Can I get that in focus at that level? Kind of. Can I come back a little bit? It really only has 2 focal points. This yeah, no, I can't do that, especially not with without the software. So okay, I'm going to move that around a bit. So this is our hole, and if I move up and down, you can see going through the depth. So that's looking into the eye of our structure, and these are supposedly or potentially transmuted elements in the bottom of this structure. Okay. And you can see this kind of like gnarly outside. Is that just where the metal yielded, or would this explain the stripes you see going in some strange radiation tracks that we looked at from Alexander Parkhomov and from the ball lightning structure of Taka Aki Matsumoto, and the same sort of thing that I saw on the lion material. Now we'll go over to its yin yang. Is yang of the yin or the yin of the yang here, and maybe play with the polarizer. So oh no, it's moved a bit. So we can pick it out. So it's too bright. There we go. There we go. With the polarizer changed, you can definitely see the structure now. Okay. So this is flat, but obviously you can see. Oh God, sorry. I need to change the tension on that. So you can see the brushed steel here, and it's completely changed the structure of that. And I've got SEM images of this, and you can see it's a very regular array in that area. And then this one is similarly an extremely hard line, but in this case, it's removed this material in a bowl, which I can show you by going in and out. So this is a bowl of material that's removed. This is like the bowl that we see in the figure of eights in the hydrodynamic structure. And this is the peak, but it's not a peak because it's kind of like maybe material is coming through subspace and it's poking up through here, and it's causing this change to the surface of the material above here. And again, it's a very hard demarcation line, not as hard as the other side, but you see this on the figure of eights. What's the green thing in the center? I don't know. I mean, I have some. I think I've got some transmutation data on this. I think I studied this in September. I studied this at Maastricht University in I think late 2007, early 2018. But I didn't have a lot of time. I think I did more work at Allen's. But I think these are various elements. But because it's a sample from 1982 and it's been with all other kinds of different materials, you can't say that the transmutation in there, and everyone and their dog is going to say that it's just contamination. But that's not important. What is important are these same shapes that are partially overlaid in a sort of hydrodynamic way, like you're seeing with these structures here. This kind of hydrodynamic structure, but it's magnetohydrodynamic. And so they have a common center. And one is an outie and one is an innie. But of course, with a flat piece of steel, it's a bit difficult to get the outie going. Oh, there's a tornado. Look at that. It's just lovely. Look at that. Go back a bit. Oh, dear. Don't you just love this? You just love it. Anyway, so so back on there. So this is the innie, and the other one is the outie. And I don't see 150 different variations in between. I just see the innie and the outie. But they do structure themselves, and this is actually part of a macro structure. So this itself is part of a much larger structure, and if we zoom out, we can see what that structure is. And this structure has rotational symmetry. And I've talked about this before. If I can actually... What's going on now? It's dropped. Yeah. So we have a structure over here, and we have a similar structure over here, and then we have. You need to look at the whole thing, but it's very similar to a sunspot, but mirrored, and that would be the case if it was the other magnetic state. Maybe I can just adjust this. You can get a better idea of how similar they are, but what is interesting here is the demarcation, the intensity of the demarcation between the material that's completely removed, and it's removed by quite a large depth, and the area that is almost completely unaffected. And I kind of see parallels with the holes, the hole and the only slightly affected area, or it is quite affected by quite a lot, in the Amasa gas exposed 10 yen coin. And at some point, I will take one of the figure of eights that we see in the Ultra experiments, and I will overlay that on the 10 yen coin, and I will overlay that on this structure in the 1986 Bullburn sample from John Hutchison. And it's kind of like, you know what? I think they're going to line up. I won't have to work hard to make that happen, because it's a fundamental structure of nature. The tornado and this pair, this vortex pair. Okay, so if there are any questions now before I close out, I think that's enough for tonight. Like I say, I think what I'll do tomorrow is actually the I'll translate the paper for the a new kind of electrical current from Taka Aki Matsumoto, because and it will be a much shorter presentation. I might do it pre-recorded, because I want to make sure that he is on the record as the first person to try and publish observation of this, specifically in relation to making a structure which he calls itonic clusters, which he recognizes like microball lightning, like natural ball lightning, and it probably is the same thing as an exotic vacuum object, and that these things can conduct into metals and then go on to affect other equipment that are attached to conductors. O is not oxygen by any chance, but oxygen is very important in water systems. Axel, the hexagon is a shape that minimizes surface to contain a given volume. Yes, and bees and hornets and wasps, they all know it. It's also an energy structure. And go and look at the nature of the energy structure of a beehive. Just go and do some research on that. This is, again, shape energy and resonance energy. Have you tried adding piezoelectric powder to the ultrasonic bath? I'm trying to keep the experiments as simple as possible. These are experiments that anyone could do an iteration of and share it for the common good for very little investment. You know, they can use the cameras that they have on their phone, which is essentially what Thomas Kaminski did when he took up the challenge in November of 2019 and produced these sprites videos. And it was... I think he shocked himself at how easy it was to produce this effect and produce it every day of the week. I think the electrical universe theory really has to take on board the presence throughout all of the universe of microleptons, and one of those is called neutrinos, or relic neutrinos left over from the so-called Big Bang, but it's not necessary really, because they can be synthesized in nova and other celestial high energy events. So you don't necessarily have to have the Big Bang to occur to produce these things, but they exist. And if you look at the work of Space Earth Human of Alexander Parkhomov, he proved their existence and how you can manipulate them, and how you can actually create telescopes to observe objects in new ways by using it. So, but certainly electricity plays an immense role. There is no doubt about that. What time tomorrow? I don't know, but as I say, I'm pretty certain, because of the significance of what I'm going to show you in the what is O, not what is O per se, but the data that I'm going to show you, it's a lot to come to terms with when you see it, because of the clarity of what it's showing you, and having seen it, and then you know, in context of what has been observed by Taka Aki Matsumoto. And I go and look at Taka Aki Matsumoto's. I'm going to talk about this in that presentation, but go and look at what he thinks are impacts of quad neutron decays in some of his papers. So you go to nanosoft.co.nz, that's the MFMP's Lena reaction database calculator, and in the bottom left on the links at the top, there is the Lena events calculator, and if you database, and if you click on that, you can then put in Matsumoto, and then you can go and look at his papers and look at the SEMs or micrographs, microscope micrographs from I think it's 1 point cold fusion, or some of his presentations. You will be able to see in those images in a completely new way with what we've been showing over the last couple of weeks. There are many individual ring spots, but there are also figure of 8 pairs that are overlapping. And he later conceded that in 2001 that it was, in fact before then, but publicly in fusion technology in a letter, that it was not just 4 quad neutrons. That they learned that it was literally trillions of atoms, or billions or millions, that are interacting simultaneously. Okay, so I think with that, essentially what we've done today is we've gone over a formally unpublished paper by Taka Aki Matsumoto, which he graciously shared with us last week, and we're going to put up an English translation alongside the Japanese of that, with the 2 microscope images in there. And this showed for the first time in my experience that the structures that we saw on the outside of the fused quartz in the Lion reactor, and that was on silicon dioxide, and that Parkhomov saw in his boron nitride reactor tube, were, as according to Taka Aki Matsumoto, and I would agree with him, they were the effect of the tornado, micro tornado, that occurs behind the exotic vacuum object. And in his particular image, he actually captured the exotic vacuum object, and that he did that because he developed a method of producing reliably microball lightning on an anode and then turning that anode off and immediately having another anode, so that the ball lightning, because it is negatively charged, would travel along a witness material, leaving marks. And so he could do this over and over and over and over again in a relatively simple experiment and produce the tracks to understand what's going on. This is a challenge for people out there in the community that have wherewithal to do that, to get better images of what Matsumoto has shown us he achieved in the 90s. And so we can really nail with high fidelity the exact process that's going on. And also, by choosing different materials as track materials, track recording materials, we may be able to understand more about what elements transmute to what elements. This is in a controlled way, by just having like one ball lightning going along and seeing the effect of one, in my view, coherent matter structure interacting and manipulating nucleons almost completely effortlessly. And then we went on to show how in the hydrodynamic model, in the Vivreal, the ultrasonic domestic jewelry cleaner, we can demonstrate the toroidal pairs and the pair production and the tornadoes being produced, and some other novel features which lined up with a kind of decompression idea. So I will say this now. I believe you're seeing decompression of water in here. I believe that what is doing the transmutation is almost like a decompression of the vacuum. And so you have your in the case of the Amasa vibrator plate, that data, you're having the chrome, which is in the steel, which is in the underlying the palladium. The chrome is being decompressed to magnesium, and the magnesium is being decompressed to carbon. And so you're seeing a decompression process, and therefore it's literally an effortless process when the EVO is in play. And so I think these tendrils that you're seeing up there, which I call sprites, are decompressing the water, and therefore if there are nanobubbles in there because of cavitation or just because there's dissolved gas or whatever, they are forming the bubbles, or it's causing a vacuum because of the intensity of the decompression. And so so you have, that is a decompression, and I think there will probably be a mirrored compression system going on. And Matsumoto referred to these as black and white holes, and I think at the end of the presentation I showed you a black and white hole on the ball burn sample from John Hutchison that was produced in 1986. So with that, I will say thank you for your time and good night, and I'll see you in the next video.